Welcome to the lecture series of Industrial Engineering with subject code KME 503. I am Dr. Suman Gothwal, working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So today we are going to discuss one of the most important topic, that is the assembly line balancing. Okay. So these will be the outline during this lecture. First we will discuss what is the assembly line balancing and what is the requirement of this. Then we will discuss how we can calculate the cycle time. Okay. After that we are going to discuss the largest number of following task rule and how it will be useful in assigning the task to different workstations. What will be the conditions or the parameters that we have to follow. Then we will take one example to understand this particular rule, that is largest number of following tasks, in detail. So assembly line balancing is an important area of the analysis of the product layout. So first is, what is the product layout? Basically, in case of the product layout, the variety of parts that we want to produce in our organization, in our layout, is less, but the quantity or the production volume is large. So it is more suitable for the mass production. Okay, and here the number of machines, or we can say the number of facilities, are arranged in the sequence of processes. Okay, or processing sequence. So this assembly line balancing method is a very important criteria in case of the product layout. Okay, and it has implications for the layout, particularly with reference to the workstations. So we are using this assembly line balancing is in assigning the tasks to different workstations. So it is basically we are using this assembly line balancing in reference to the different workstations. So on the we will assign the tasks to different workstations and we will decide the size of those workstations. A workstation, now what is the workstation? Workstation, we can say it is a physical locations in which one or more tasks are performed. Okay, and while assigning the task to different workstation, our objective should be to assign the task to different workstation in such a way that each workstation completes the assigned task in less than or equal to cycle time. Now we will see how we can compute the cycle time. Okay, so cycle time, first we have to understand what is the cycle time. So cycle time is basically the time between the successive products which are coming out from the end of an assembly line. So it is the time between the two successive products. Okay, so we can calculate this cycle time as the production time per period. Okay, whatever is the production time per period and the required production quantity in the same period. Okay, so our objective will be to assign the task to different workstation in such a way that the particular task can be completed in the time which is less than the cycle time. Okay, so now we come to the largest number of following task rule. So as per this rule, there are some requirement for implementation of this rule. First of all, we have to draw the precedence diagram. So this diagram is basically the relationship among different tasks. Okay, so with the help of the diagram, we will represent the relationship among the different tasks. We should know what is the required production quantity per period, because we want to calculate the cycle time. Okay, and time taken by each task, and we are denoting it with Ti. Okay, as the name of the rule suggests, assignment of the task will be in the order of the largest number of following tasks. okay, and it will be helpful if the number of tasks which follow is each task are known to us. Okay. So, there are some conditions and there are some information that are required to implement this particular rule. So, first we have to show the relationship among the different tasks. We have to determine the time taken by each task. Then we require the production quantity per period, and we also need the information about the number of tasks that are following each task. Okay. Now, we have taken one example here. So, in this example, basically an assembly line involves tasks from A to I. So, there are number of tasks are involved in this situation or in this example, and these are from A to I. So, you can see the task here A to I. 360 products are required per day. So, here the production quantity is given, which is 360 per day, and the production time is 8 hours per day. Okay. So, production time in the same duration is also given to us. So, with the help of these two quantities, we can find out the cycle time. The time taken by each task and the task which immediately precede each task are given us. Okay. So, here we can see these are the number of tasks that are involved, and these are the tasks which immediately precede. So, we can see here no task is preceding A, means our precedence diagram will start from A. Now, the precedence of task of B is A, for C is A, for D is C. So, in this way we can draw the precedence diagram. Now, the time to complete the task is also given for each task. For example, for task A, the time given is 40 seconds. For task E, the time is 20 seconds. For H, the time is 30 seconds. So, we will use all these information and we will assign the task to different workstations. Now, I have again draw this table here so that we could draw this precedence relationship diagram. So, first we can see from here that no task is preceding A. So, our precedence diagram is starting from the task A. Okay. Now, the precedence of the B is A. So, B is A. Okay. And for C, it is again A. So, two tasks are preceding the A, task A. Okay. Then we can see here C is predecessor of D. So, D is here, it is coming out from C. Okay. Then again we have C task before E. C task is before E. Then B task is before F. So, B task is before F. Now, G task, we have D and E task before G. So, we can see here that D and E are before G. After that, we can see here the F task is before H. F task is this one, F task is before H, and after that G and H are before I. So, G and H are before I. So, using this table we can draw the precedence relationship diagram. So, this diagram is basically showing the relationship between different activities. Now, after this, what we will do, to implement this rule, we have to first make the table for different tasks, and in this we will also indicate the total number of tasks which follow it. Means we will write the a number for the task A. Means here we will write the number of tasks which are following A. So in this diagram we can see here that the number of tasks which are following A are 1, 2, 3, 4, 5, 6, 7, 8. So 8 number of tasks are following A. Clear? Number of tasks which are following B is 1, 2, 3. So we will write down 3 here. After that, C. So we can see here the number of tasks which are following C is 1, 2, 3 and 4. Okay. For D, 1 and 2. Okay. For E, 1 and 2. For F, we can see here this is F. So 1 and 2. For G, it is 1 only. For H, it is 1 only, and for I, it is 0. Okay. So after making this table, what we will do, we will arrange these tasks in the decreasing order of number of following tasks. So in this table, we can see it is almost arranged in the decreasing order. Only we have to swap these two tasks B and C. So we can write here task A is 8, task C is 4, for B it is 3, for D it is 2, for E it is again 2, for F it is 2, G it is 1, for H it is 1 and for I it is 0. So we have arranged it in the decreasing order of number of following tasks. Okay. After doing this, what we will do, we will calculate the cycle time. So before assigning the tasks to different workstations, we need to find out the cycle time. Okay. And why we need to find out the cycle time? Because our objective is basically to see that no workstation should consume more than the cycle time. So in order to achieve the production target. So here we can see here the cycle time is basically the production time per day and the required production quantity per day. So production time is given to us, which is the 8 hours per day. So we will convert it into the seconds, and production quantity which is given in our problem was 360 days. Okay. So we will find out the cycle time which comes out to be 80 seconds. So we have to ensure that no workstation complete its task in more than 80 seconds. Okay. It should be less than cycle time. So first task is in the order will be A, because it is following the maximum number of tasks are following A. Okay. It is having maximum number of the following tasks. So first we will assign the tasks to workstation 1. So we have already taken that the first task in the workstation 1 will be A. Okay. And from the previous table, we can see that the time to complete the task for A is 40 seconds. Okay. So we will use this 40 seconds here. Okay. A is taking 40 seconds to complete the task, but the cycle time is 80 seconds. Okay. So we can say the time which is yet to be assigned will be the time which is yet to be assigned will be 80 minus 40 seconds. This is 40 seconds. Okay, so we have 40 seconds time available with us. So what we will do, the set of tasks which may be assigned at this stage without considering the feasibility is, we will take it from the precedence diagram. So we can see here that the number of tasks are B and C. Okay, these tasks can be assigned to workstation 1, and we are not checking the feasibility here. We are just assigning the number of tasks or set of tasks which can be assigned here. So B and C without checking the feasibility. If we check the feasibility, then we can see the time taken by B and C are, we will see from the table, the time taken for B is 30 and time taken for C is 35. So we will write down it. For B it is 30 and for this is 35, and both are feasible because the time taken by these two tasks are less than the time yet to be assigned. So set of feasibility task will become B or C. Okay. Now what we will do, we will select one of the tasks which we can assign to workstation 1, and this selection will be based on the largest number of following task rule. So we will see from here, from this table. Okay. So largest number of following task is for C. So we will select task C for the workstation 1. Okay. So we can write down the time which was yet to assign was time yet to be assigned was 40 seconds. Okay, and we are selecting task C for the assignment. Okay, so if we assign the task C, then the remaining time will become 35 seconds is equal to 5 seconds. Okay, only 5 seconds are left. Now we will check the set of tasks which can be assigned without checking the feasibility. So we can check it from the precedence diagram. So from here we can see that the B was already the task which can be assigned. Now C we have already assigned. So now we can assign the task D and E also. So set of the task which can be assigned will become D, E and B. Okay, without checking the feasibility. Without checking the feasibility. Now if we check the feasibility, then we have to check what is the time taken by these tasks. So for D we can see here, for D it is 30, for E it is 20 and for B it is again 30 seconds. But we have only 5 seconds, means time yet to be assigned is 5 seconds only. So we can see here the task which can be assigned to workstation 1 is nil. Okay, so we have completed the workstation 1. Okay, and in this we have assigned 2 tasks only, A and C. So in workstation 1 we have assigned 2 tasks, A and C. Now we will come to workstation 2. Okay. So, for workstation 2, this was the set of tasks which can be assigned without checking the feasibility. So, we will write it here D, E and B. Okay. Now, as per the largest number of following task rule, we will see which task we have to select. So, B, D, E. So, we can see here the task B is having the largest number of following tasks. So, we will assign B to workstation 2. Okay. So, if we will assign the task B, the cycle time for the workstation is 80 seconds and for B it is 30 seconds. So, the time which is yet to be assigned will be time remaining, we can write it, remaining time will be 80 minus 30 is equal to 50 seconds. Okay. So, we have 50 seconds which we can assign in the workstation 2. Okay. Now, we will select the set of tasks which can be assigned. So, from the precedence diagram, we will see we have assigned task B, we have assigned C and we have assigned D. We have already D and E with us, then it will become F. F means D, E and F set of tasks which can be assigned now. So, we are doing for the workstation 2. Okay, workstation 2, we have already assigned B. Okay, we will write the next assignment here. So, we have 50 seconds left with us and as per the largest number of following task rule, we are assigning task. Okay, we have assigned the task B already. Now, the set of tasks which can be assigned are D, E and F. And for these, we can see the time is task completion time is 30, for E it is 20 and for F it is 45. Clear? Now, we will see as per the largest number of following task rule. So, all the 3 tasks are having the same number of tasks which are following these. So, there is a tie here. So, in this case, what we will do? We will find out the solution by taking the task which is having the maximum time. Okay. So, here we will select the task F to be assigned in workstation 2. So, the remaining time will be remaining time after assigning task F will be, we had 50 seconds and the task time for F is 45. So, 5 seconds are left. Okay. Now, again we will check the set of tasks without checking the feasibility. So, we are already having the task D and E. Now, we will again see it from the precedence diagram. So, we have assigned F also. Now, we can take the H. Okay. So, the set of tasks will become D, E, H. Okay. So, now what we will do? For this, the largest number of tasks are 2. For this, it is again 2 and for H, it is 1. We can see it in this table. For H, it is 1. Okay. So, what we will do? Now, we will randomly take any task which we will assign. For example, if we are assigning the task D, for D, the time is 30 and for E, the time is 20. But we will prefer that we assign the task which is having the largest or high task completion time. So what we will do, we can take the set of feasible task is this. For this the time is 30, for this 20, and for this it is, for H it is 30. Okay. Set of feasibility task, if we check, we have only 5 seconds left with us in the workstation 2, but here the time is more than the 5 seconds. So we cannot further assign any task to workstation 2. So the number of tasks that we can assign, or the number of feasible tasks that we can assign to workstation 2 will become nil. So the tasks which are assigned to workstation 2 are B and F. Okay. Now we will move to the workstation 3. Okay. Cycle time, again we have 80 seconds. Okay. And the set of tasks which can be assigned are D, E, H. Okay. And the number of tasks which are following these are 2, 2 and 1. Okay. So first we will select from the D or E. So there is a tie between the number of tasks which are following these two tasks. So we will select the task which is having the high or which is having the large task completion time. So from here we can see for E it is 20 seconds only, and for D it is 30 seconds. So we will select the task D. Okay. And if we talk about the feasibility, so all these are feasible because all these are less than 80. So D, E, H. Now remaining time will be time after assigning task D will be 80 minus 30 means 50 seconds. Okay. Now we will again check the set of tasks which are or which we can assign. So we have E and H with us. Now we will see the precedence diagram again. So H is with us and D we have assigned, but we cannot take G in the number of tasks which can be assigned to workstation 3, because until the D and E are completed we cannot select G. So first we have to complete the task E. Okay. So now these are the feasible tasks E and H. Now we will see the time, it is 20 and it is H, for H it is 30, and as per the number of following tasks, for it is 2 and for H is 1. So we will select the task E, and both these tasks are feasible tasks here because we already have the 50 seconds left with us. Okay. So T will become E, H. Okay. Now we will assign the task E to workstation 3. Okay. For workstation T is equal to EH, we will write down here. Okay, we are assigning the task, so remaining time will be become, it was 15 seconds. D we have already assigned. Okay, so we will write it here, D plus after assigning E will become 50 minus, for E it is 20. means it will be 30. So, we have assigned E. Now, the set of tasks which we can assign to workstation 3 will be S will become H will come from here, and now D and E both are assigned. D and E both are assigned. H is also assigned. So, it will be G. Okay, and we cannot take I until the G is completed. G is assigned. So, the set of tasks will become H and G. Okay. Okay, H or G. Now, as per the largest number of following task rule, the number of tasks which was following H was 1, and the number of tasks which were following the G was also 1. Okay, and the time taken by this is 30 and the time taken by G is 50. Okay. Now, we can see here that there is a tie between the H and G. So, what we will do? We will select the task which is having the high task completion time. For G, it is 50, but we have 30 seconds left with us for the workstation 3. So, automatically we will select the task H. So, we can say that the task which can be assigned, or the feasible task which can be assigned to workstation 3 is H. So, remaining time will be 30 minus 30 is equal to 0. Okay. So, for this it will become H. Now, we come to the workstation 4. Okay, so set of feasible task with us is G, and now it will become I also. Okay. Now, what we will do? So, the number of tasks which are following this one is 0. For this the time is 50 and for this the time is 35. Cycle time is 80 seconds. So, set of feasible tasks will become G. Okay. This is the T. Now, okay. Now, we will assign. So, remaining time will be, as per the largest number of following rule, we will assign G here. So, the remaining time will be 80 minus 50 is 30 seconds. Okay. So, the G is assigned in workstation 4. Now, we will see whether we can assign the other task or not. So, we have left with I only, and for each the time is 35 seconds. So, we have left with 30 seconds only. It means we cannot assign any task further in the workstation 4. So, set of feasible tasks will become nil. Now, when the workstation 5, then we have left with one task only. So, we will assign the task, this task I, into the workstation 5. So, in this way we can assign different tasks. Now, we can find out the performance of this layout also, or we can say we can find out the performance of the proposed solution also. So, for this we have one formula, that is efficiency percentage will be theoretical minimum number of workstation, actual number of workstation, into 100. Okay. So, here the actual number of workstations are 5. okay, 5 workstation. Now the theoretical number of workstation will be total task time divided by cycle time, okay. And what will be the total task time? Total task time will be the time of each task, which will become 40 plus 30 plus 35 plus 30 plus 20 plus 45 plus 50 plus 30 plus 35 divided by what is the cycle time? It is 80. It means it comes out to be 3.93. Now we can find out the efficiency of the proposal as 3.93 divided by 5 into 100. So efficiency comes out to be 78.75. So using this rule, we can assign the task to different workstations, okay, and we can find out the efficiency of that particular solution also. So that is all from my side for this lecture, and these are the references. This is the reference Introduction to Operation Management by Dr. Sanjay Sharma, and so thank you very much.